We're going to talk about the statistical concepts of estimation and hypothesis testing. And these are two of the major tools that you will use in your statistical training. So to recap where we are now, we've talked a lot about distributions, and we've talked about if you have a distribution of individual people, for example, this distribution of height of women in the US, we can describe them with the measure of central tendency, the mean, and we can also talk about the spread of that distribution. So for example, if you look at this normal distribution here, you see that the standard deviation would be something around 3. The average woman is 5'7". Probably the average woman in shoes is 5'7". And then we see that there's a spread, and some are taller than average and some are shorter than average. So this is the standard deviation, and we use it to describe the spread of individual people around the mean. Now, we saw that we can take individuals in that distribution and we can reference them. So we can think of this in terms of probability too. What's the chance if I choose a random US woman that her height is more than 6'1"? Well, we can look at 6'1", and we can look at the area under the curve to the right of that. And we know that this is 2 standard deviations from the mean. We know those magic numbers, 95% are within 2 standard deviation. So something around 2.5% of women are taller than 6'1". So this is the idea of using individuals and thinking about the standard deviation to describe their spread. The second concept we added was the idea of the sampling distribution of means. So imagine that you went out and took a sample of women, say 36 women, and then you calculated the mean each time you took a sample. Each time you would get a different mean. It's not because you suck at science and you can't replicate your numbers. It's because the mean is a random variable, random sample, random heights, random mean. So this bar here would represent the distribution of the sample means. This is a weird concept, but this acknowledges that every time you take a mean, you would get a different number. Every time you take a sample, you would get a different number. This also is centered around the truth because our samples are unbiased. It's not like we're picking only short women or only tall women. And the spread of this is described by a number called the SEM, the standard error of the mean. It's how much the means bounce around by chance if you were to repeatedly sample over and over and over. And as we saw, this is determined by 2 things. One is your sample size itself. So the bigger the sample, the better you can hone in on the truth. Also, it's driven by how spread out is the population itself. When this is very wide and there's a lot of variability, your means will also bounce around a lot. So for this example, we could say, let's erase this here. For this example, we could say that the spread of this SEM is about 3 divided by the square root of 36. So that's 3 over 6. So that's about 0.5. And if you look at this curve right here, you see that the spread of this curve is about 0.5. So the standard error of the mean is the standard deviation of the sample means. This is a weird concept that's maybe the hardest thing to understand in this course, but when you get it, when you appreciate that the mean is a random variable, then it opens up a door to a lot of stuff. And what it opens up the door to is this. Because we know that these means are going to be normally distributed based on the central limit theorem and this applet which we played with in the previous slides. Because this is going to be normally distributed, now we can do 2 very important tools in statistics. The first one is called estimation. Estimation is the idea where you take a sample. What do I learn from this sample? What does it tell me about the truth, the population mean? So we use a sample statistic to talk about a population parameter. And related to this, very similar to this, is the idea of hypothesis testing. So we can take some parameter in the population and make a hypothesis about it, and then collect some data and say, if the hypothesis is true, what's the probability that I would get the data that I got? And as we've seen again and again, this is the definition of a p-value, the probability of observing a test statistic of a given magnitude or larger if the null hypothesis is true. We saw this slide, and we spent time on here thinking about if we have a population, and if we spent time repeatedly sampling over and over and over again, taking small samples, how would those statistics behave? We talked about central limit theorem, standard error of the mean, and so on. But today we're going to see when you take one sample, when you take one study, what does that tell you about where that parameter is? I had a really good statistics books once, and it was called Statistics, A Guide to the Unknown. And then I realized that that's sort of a joke. The parameter, the population number, is unknown. And we take a little sample, a statistic, and we say, what does this tell us about where that unknown thing is?